This is our third video for Chapter 6, and we will again be looking at the time value of money. We have 4 questions we're going to be answering based off the time value of money. What we'll be focusing on these questions is understanding, are we solving for the present value or future value, and what factor we need to use, whether it's present value, future value, present value of an ordinary annuity, or an annuity due, and the same thing for the future value. So that's what we'll be looking at in each of these questions, and I will read each of them in detail on the following slides. Let's look at our first question. How much must be invested now at 9% interest to accumulate to $10,000 in 5 years? So a couple things to notice here. We want to know how much must be invested now, 9% interest. We want to be at $10,000 in the future in 5 years. So we're looking for the present value of a single sum, and that single sum is the $10,000. So it's the present value of a single sum problem. So to find the present value, we take the $10,000 future amount and multiply it by the present value of $1 factor, and we need to know the periods and interest for that. So the number of periods is given in the problem, 5 years, n equals 5. Interest is also given, 9%. So we look at our table up here above. 5 is our number of periods. It's showing 9% for all of these factors. So we look at the present value of $1 is 0.64993. So we multiply 10,000 times 0.64993. That's going to give us our present value amount that we need to invest now, and it's going to be $6,499.30. Our next question, how much must be deposited at the beginning of each year in order to accumulate to $10,000 in 4 years if interest is at 9%? So it's asking us how much must be deposited at the beginning of each year. So that tells us that it's going to be an annuity due problem, because annuity dues are always deposited at the beginning of a period, whereas ordinary annuities are done at the end of a period. And we want to accumulate to $10,000 in 4 years, and again the interest is 9%. So this is going to be a future value of an annuity due problem. So the formulas to solve for this starts with the future value of annuity due total, which is the $10,000. And that's going to be equal to our future value of an annuity due factor. So we need to know our period for that, and it tells us in the problem 4 years. And the interest is again 9%. And we multiply that by the payment amount. So the payment is what we're looking for. We want to know what our deposit or payment needs to be at the beginning of each year to get to this $10,000. So we need to know what these future payment amounts are so we can get to this $10,000. So we can set up, or we can fill in our numbers. So we have the $10,000 here that we're given in the problem. We can look at our future value of annuity due factor with 4 periods. It's going to be right here, 4.9847. We plug that in here, 4.9847. That's our factor. And then that's multiplied by the payment. So some basic problem solving here. We're going to divide the 10,000 by the factor, and that will tell us what our deposit needs to be at the beginning of each year. So doing that, you get $2,006.14 for our deposit at the beginning of each year, and doing that for 4 years will get us this future amount of $10,000. Our third problem, Emma Watson will deposit $5,000 into a money market sinking fund at the end of each year for the next 5 years. How much will accumulate by the end of the 5th year if the sinking fund earns 9% interest? So So looking through the problem here, I'm going to deposit $5,000 at the end of each year for the next 5 years. Okay, and we want to know how much will accumulate by the end of the 5th year at 9% interest. So if you notice, it says at the end of each year. So that means it's an ordinary annuity. And we need to know the future amount, because we want to know at the end of the 5th year. So this is a future value of an ordinary annuity problem. So we want to know what that total amount is going to be. So we're solving for the future value of these ordinary annuities. And just like the last problem, we set up our equation. That's equal to the payment times the future value of an ordinary annuity factor. And that's going to be N equals 5, because it tells us deposits will be made for the next 5 years. And again, interest is 9%, which we're told in the problem as well. So let's plug in what we know. We know the payments are $5,000. It tells us that here. Let's look at our table to find our number for the factor. It's N equals 5, and we're looking at the future value of an ordinary annuity. It's going to be 5.9847. And if you multiply those together, we'll get our total that will be in the money market sinking fund at the end of the 5th year. It's going to be $29,923.50. Let's take a look at our fourth and final question. Epic Highs Incorporated sold the rights to use one of its patent processes that will result in cash receipts of $2,500 at the end of each of the next 4 years, and a lump sum receipt of $4,000 at the end of the 5th year. What is the total present value of these payments if interest is at 9%? So let's look at a couple things in the problem. We can see there's going to be $2,500 receipts at the end of the next 4 years, and then a lump sum receipt of $4,000 at the end of the 5th year. We want to know the total present value of all of these payments, with interest again being at 9%. So this is what we call a problem that's looking for the present value of mixed cash flows. And we call it mixed because we're looking for not only the present value of multiple payments, but also we are looking for the present value of one single lump sum. So what we're looking for here is first the present value of these 4 $2,500 payments at the end of each of the next 4 years. So being that it's at the end, that's going to be a present value of ordinary annuity. So we want to solve for that. And we also need to know the present value of this one lump sum receipt of $4,000 at the end of the 5th year. So we're looking for the present value of a single sum in that instance. So let's look at our formula to solve this. We're looking for the total present value, which is equal to the $2,500 payments at the end of the next 4 years times the present value of an ordinary annuity factor. So let's figure out what the number of periods are. We look in the problem and it says at the end of the next 4 years. So N will be 4. And interest again is 9. Then we add that to the present value of this $4,000 lump sum receipt. So $4,000 times the present value of $1. This time there'll be 5 periods because it's at the end of the 5th year. So N equals 5. Again, interest is 9%. So let's start solving that. 2,500 times present value of an ordinary annuity when N is 4, interest 9%, it's going to be 3.23972. And if you multiply those you'll get $8,099.30. Next, you take the $4,000 lump sum, multiply it by the present value of $1 when n equals 5, and 9% interest. It's going to be 0.64993. And that's going to equal $2,599.72. So if you add those together, we will get our final answer, the total present value of these payments, and it's going to be $10,699.02.